Hey, and welcome to another data structures video. This time around, we're going to be going over one of the simplest data structures called the stack. And we're actually going to be there are several implementations of a stack, but we're going to be going over the array-based. And so we're going to go through the fundamentals of the operations of a stack, and then we're going to go into coding it. Okay, so let's get started. Now, a stack is just a collection of objects that are inserted and removed according to what's called the LIFO principle. So it's last in, first out. So in this example here, we have three operations. We have the first one, we push the number 5 onto this stack. Okay, so think of a stack as like stacking pancakes. You know, you're putting one on top of the other. So what we do is whenever we want to put something onto the stack, it's called a push operation. All right, so what we're doing first is we're pushing the number 5 onto the stack. So now that is the first thing on the stack. Okay, and the second operation is to push the number 3. So when we push number 3 on there, it goes on top of the stack. Okay, so that means 5 was already there, and then 3 goes on. Then 5 was here, then 3 goes on top. All right. Then for the third operation, we push 8 on there. And so now it's 5, 3, and then 8 that we just put on the stack. Okay, so again, whenever you want to add to the stack, it's called pushing onto the stack. So we're going to use a push operation. Now, if you want to take something off of the stack or remove, we call it the pop operation. All right. So here, you don't specify there's no input on the operation. Okay, there's no parameters. You're just calling the pop operation, and it just takes whatever is on top, takes it right off. All right. So here in this example, when we call the pop operation, it's taking 8 off because it was what was on top of the stack. So to go back to the LIFO principle, last in, first out. When we pushed 5, 3, then 8, the last one that was pushed on was the number 8. And then when we popped off from the stack, removed something, the first one was the number 8. So the last one in was 8. The first one out was 8. So last in, first out. That's where the principle comes from. Okay. So when we get ready to the coding portion of the stack, the array-based stack, there are 5 operations that we're going to code. Okay, and then we're gonna have like a test class. The first two are what we just discussed: the push and pop operations. So we need to push stuff onto the stack, and we need to pop stuff off of the stack. Okay, so we're adding or removing from the stack. And then the next 3 are kind of like helpful. They're kind of helper functions. So the top operation, what it does is it returns the element that resides on top of the stack without removing it. Okay, so pop does it returns the element that's on the top and removes it. Top just returns the element without removing it that was on top of the stack. Okay, is empty. We just check to see if the stack is empty or not. And then we have a size operation that just returns the number of elements in the stack, and that's it. Okay, so obviously we have to have a private variable called size that always keeps track of how many elements are on the stack. Or technically it's just an array, okay? Because we're making an array-based stack, so it's just really what's going to be in the array. So the index 0 is always going to be the bottom, and then the number of elements in there, or n, is going to be the top, okay? So now that we kind of have a basic idea, let's just go ahead and start coding. All right, so now we're here at the coding portion of the stack. And again, it's an array-based stack, okay? So go ahead and create your stack class, and let's get started. There are a few things that we need to make sure we have first, okay? So we're going to start with something with an initial capacity for a stack, all right? So the problem with an array-based anything is that you have to start with some initial size, all right? And that can be limiting. And we will have another video where we code a stack in another data structure where we don't have to worry about that, okay? But for now, we're learning about the fundamentals, and make sure we know how they work. All right. So what we're going to do is we're going to create a few private variables. The first one is going to be the initial size we want for our array-based stack. And then we are going to create the initial array. Let's call it data. And then we're going to also have our initial size. This is going to keep track of the how many elements we have in the stack. All right. So now we can go ahead and create our constructor. This one is we're going to take in, we're going to have two of them. Okay, and so this one we're just going to, if you want to make it any size, okay. So we're going to say data equals new int and capacity. Okay, and then we have public stack. And what this is going to, all this is going to do is we're going to say we're going to take the constructor we just created. So we're going to use a this keyword, right? And we're going to put in the capacity, the final static variable capacity, which is always 100. And we're going to pass that in. So whenever we create a stack, if we use this constructor without a parameter, it's just going to be a size of 100. Otherwise, you can initialize it to however the size of the array you want. All right. Okay. Always start off with the simple methods first, just to kind of get them out of the way. And normally they're helper methods, so we'll probably be using them in the methods that actually require some logic. Okay. So first one is let's just return the size of the array, or how many elements are in the array. Sorry, I can't speak. So all we're doing is just returning size. Okay, and this is one of the helper methods we said. So the next one is going to be is empty. So it's going to be a boolean is empty. It's going to either return true or false. So what we can do, you can do it in if else statement. So you can do if let's see, we can do if size equals 0, return true, else return false. We can do that. That works. All right, but there's gonna be a little simpler way. It's on one line. You could say return size equals 0. So if the size equals 0, then just returns true. Otherwise, it's going to return false. And it's just a little cleaner. Okay, it's just more of an implicit way of coding that if else statement. So the next one is top. Okay, so all this does, again, it returns the element that's on top of the stack. So in order to do this, first thing we need to make sure that the stack actually has elements in it. So if is empty, we're just going to return -1. We have to return -1 because that's what value this method is expecting to return. Now, typically, you could use generics, and so that you don't have to specify, like our array we specified to the int primitive value, or we make sure it's a int, like all the data is going to be int values. Okay, typically when you use generics, you can do it in a way where the user can choose what type of the value they want to use. Okay, but for now we're returning -1, and you can't return null for a primitive int as a primitive int value. Okay, so first off, we need to make sure it's empty. If it's true, we would just return -1. Otherwise, we're going to return data size -1. Okay, and that's what's going to be on top. So again, we have to say size -1 to get the size, or to get the actual value that's on top of the stack, or the last value in the array. Okay. All right. So now we got the helper methods out. Now the last two are the push and pop methods. So let's do the push one first. Public. Make some space down here so you can see. Public int. Sorry, pushing first. public int avoid push. We're not returning anything when we push. We just put it on the stack, and that's it. Okay. And then we're going to say some number. Okay. If size equals 0. I'm sorry. So okay, there's a couple things that are happening here. Kind of stop talking there for a second. So if, again, because it's an array-based stack, if if we fill up the stack, okay, and we try to push again, well, we can't unless we do something about the array. In this implementation, we're not going to do anything with the array. We're just going to throw in an error that you can't put anything else on the stack because it's full. But you could, typically you would double the size of the array, but that's kind of costly with an array, which is why like a single linked list is a little better because you don't have to worry about increasing the size. It's kind of done every time you put something on on the linked list. But for this example, just to kind of get the fundamentals of a stack, we're just going to say if the size is equal to the length of the array, then that means it's full. Okay, so we're going to throw, it's called legal state exception. Okay, let's say stack is full. All right. Okay. And we don't care if it's empty, then it doesn't matter, right? We only care that if it's full or not. That's all that matters. Then we're going to say data of size plus equals none. So what this is saying, this is essentially saying we're going to take this current size, however many elements that are in there. We're going to take that index in the array. We're going to set that equal to the number that's being put as the input. Okay, and then we increase the size of we increase the size variable. So this is the same as saying that. Okay, it takes whenever you do I forget what this is called, like post operation or something on this variable, then that's just it's gonna perform that line of code and then increase the size variable. Okay, so basically we're just adding to the end of the array and then increasing, adding 1 to the number of elements that are in the array to keep track. So then the last one we have is public int pop. Again, this takes no inputs. And for here, you don't want to take off the stack if there's nothing on there. It's just a wasted operation. So if is empty, return -1. Okay, first off, do that. So we're going to say we do need to return the data element that was on top of the stack. So we're going to say data size -1. So this is just returning the element in the last element in the array. Then we're going to say data size equals -1. We're just gonna set that what was there to -1. Okay, to kind of note that it's no longer an actual value for this example. And then we decrease. Okay. Oh. Is that right? Or what's going on? What is it saying is off here? Oh. Oops, sorry. Then you have to return the answer. So make sure you have a return statement when it's not a void value. Okay, so now we are done. Now all I'm going to do is kind of have like a small print method, just so that we can see in our test case. So we're just going to have a loop. Is less than size plus plus. If you guys have any questions, make sure to put them in the comments, and I will get back to you, and so that you can help, so you can make sure that you understand what's going on with this data structure. Okay. All right. So I'll slowly go through this so you can see if you need to pause the video to make sure you have it correct. Okay. Now in the main method, I've already kind of created this before, like a little. This is just a little like test that I created. So the first thing we're going to do is so we're going to push 100 onto the stack, and then we're going to push 5. So that means the bottom is 100, and on top of that is 5. Then we're going to see what's on top, so that should then return 5, and then we're going to pop it off, okay, which should return 5 again. And then when we call the top method, it should say 100. Okay, that's the expected output anyway. So let's see if it worked. Okay, so we pushed 100, then 5. See the top method. Okay, so it's saying the top is 5, which is correct. We popped off 5, so it's going to return 5 again. Then what's on top is 100. Then we just printed the stack, which is only 100. So let's actually do this, and we're going to do. This will be a little better. Let's print everything. Let's make this 9. This will be a little better. Let's see. Oh, that's why. If you had a little print statement there, it's not going to the new line there. Okay, that's better. All right, I thought I was incorrect for a second. So we put 100 on the stack, then 5, then 9, then 88. So it should be the reverse order, right? So 100 is on the bottom, then 5, then 9, then 88. And that's correct with our array, okay? Then we print it. So we printed all that, as it showed there on the first line. We printed out what's on top, which is 88. We popped off from the stack, which also returns what was on top. So again, that was 88. We just checked. Then we check again what's on top, which should be 9, and it is because we already popped off 88. And then we print the stack again, and it's the same stack as before without 88. Okay? And let's see if we pop, see, 3, and then we do it a 4th time. I believe it should return -1 at some point. Yep. So in our code, when we pop, if it's empty, it ends up returning -1. So after it removes 100, it returns -1 because there's nothing else there. Okay, again, if you have any questions about this, leave them in the comments and I'll get back to you. This is one of the simpler data structures that you need to learn because it's used in a lot of applications. Okay, and we'll use it later on for other things. A really good example is if you're in a text editor, and even like right here, if I need to undo something, you keep on a stack like what I did if I typed a semicolon and then I typed a parenthesis and I typed public int pop. Okay, so the last thing I just did was type public int pop. Well, if I want to undo that, it keeps it on a stack. So when you hit Control Z, is you're basically popping off of the stack, which was me typing public int pop. Well, then it knows to erase what I just typed because that's the last operation I did. So it keeps everything on a stack, and then when you undo, it just keeps removing from the stack the last things that you did on your text editor. Okay. So hope this helped. I hope you learned a little bit more. Again, if you have any questions, leave them for me in the comments, and I'll get back to you. I'll see you next time.